Hello, Professor Sargent here with you. This video is a one-off. It is based on the response I saw to a question about logarithms, how one of my students responded to it. I'm not calling that student out, but I saw something interesting and saw a way of fixing the response that I wanted to cover. So the question was to take 6th root of 64 equals 2, which is a true statement, and write it in logarithmic form. Now, what they're expecting is to rewrite 6th root of 64 as 64 to the 1/6 power equals 2. Since the answer to a logarithm is an exponent, then the question is, what's the base and what are we taking the logarithm of? Well, the base is 64. And by a process of elimination, that just leaves the 2. Well, what my student had done was to raise both things to the 6th power. Which canceled out over here and gave us that 64 was equal to 2 to the 6th, which is easier to recognize as a true statement than this might be. In fact, knowing this would confirm this. Well, these are different statements. They're related, but they're not the same. And so what he did then was said, okay, the answer to a logarithm is an exponent. So now he sees the 6 as an exponent instead of a 1/6, and the base he had as 2. So by a process of elimination, taking the logarithm of 64 in base 2. That would be saying what power of 2 would give you 64, and that is going to be 6. So what I noticed about this is that we're seeing a reversal of the base and the, I believe it's called the argument of the logarithm, and that these were reciprocals of each other. Will that always be true? Let's take a look. So the question here is, if we have an acceptable base where it's positive but not equal to 1, and also remember you have to take the logarithm of positive numbers, then if we start out with this, but instead we compute this, would this always be the reciprocal of the answer we were looking for? So again, we're looking at the argument and the base getting reversed over here. So let's start off with this. Log of A in base B, call that x. Then by definition of logarithms, the answer to the logarithm is an exponent. So that would be base B to the power of x, and that is equal to A. If I take both sides here to the power 1 over x, then on the left-hand side, these are canceling out. Remember that the range of a logarithm is any real number. Let's see here. So I would be worried if x was 0. Come back to that in a moment. But anyway, on the left-hand side, cancels out. Now we have b equals a to the 1 over x. And we could again apply the definition of logarithms. We have a base of a the exponent of 1 over x. And so by a process of elimination, now we're looking at the log of b in base a equaling 1 over x, which I called this. So that is one way of confirming the statement. Give me just a moment though, because we should worry about our exponents here. And really, in this case, it doesn't matter what we have called x. We're not even writing that. As long as you are taking here the logarithm of positive numbers, then this is going to be true. That's all I've got for now. Just an interesting thing I wanted to share. See you in the next one.